Hello, and hello again, and welcome back to the programming bootcamp of Code Maven. My name is Gabor Savo, and hello, Nora, back again.
Hi.
Yes, so this time I'm going to share the screen already, and this time we're going to talk about functions. So yeah, so this is just the main slide, nothing really interesting here. You are already used to finding the slides, and this time we're going to talk about functions. Let me just drag this image here so it's going to be easier for me. Okay, so the first thing is the question, why use functions at all? And let me enlarge the fonts a little bit. So there are two main, I mean, maybe there are more, but there are two main goals that I can think of for using functions. One of them is code reuse. And you might find that this is some sub-idea of the try idea of programmers, which don't repeat yourself. There's a link for more explanations if in case you're interested. The idea is that to have the same thing only once in the code, because if you have it twice, then at one point you're going to update in one place and forget to update the other place, and then it's not really a good idea. That's actually one of the reasons I always love that when programmers talk about marketing, and in marketing is just everything about repeat, and programmers are really have hard time with it. So anyway, the functions is for code reuse. So instead of doing some calculation in two different places in your program, you move it out to a function, put it in a function, and then you call it with two data sets. And then you get back the calculation. So you have the operations in one single place. The other one, the other main thing that I think it's really useful functions is to create small units of code. So to break up your code into pieces that are understandable, easily understandable, that usually the sort of what people say is that you have one thought in it, or a single responsibility for each function. So it does either this or that, and not many things. It's going to be easier to understand for the person who reads it. And obviously it's going to be easier. And we are reading it a lot of times. So when we are even writing the program, you have to reread some of the programs very soon. I mean, so far, I think the longest programs you wrote were maybe the game was so far the longest in terms of lines of code, and that was already, I think, 40-50 lines, right? Maybe even more.
Okay. Probably a bit more.
So it already had a couple of if statements, and this case and that case, and that can start to be complex, and we have to start thinking, okay, so what did I do there? And these interconnections make it really hard to write the program. So it's easier to understand when the smaller the units. It's easier to test each unit. So if each unit, I mean in this case function, but if you have this function and the input and the output of the function is well defined, okay, then and it doesn't have side effects, and I'll talk a little bit about this later, then it's really easy. It's much easier to test with various types of input, checking whether they correspond, whether the output is what you really expect. And then once you tested it, you can rely on it. And then you more or less you can forget about it. And that's very important, because we are not able to concentrate on so many things at the same time. Okay, and then of course this also leads to easier maintenance when you have tests and understand well and so on. So functions are really important. And then later on, once we have functions, and I think in the next chapter, we are going to move over to modules, when you'll be able to reuse the same function around several programs. So that's going to be easier, even nicer reuse. Basically the same way as you can use modules of other people, like the CSV module we mentioned earlier and other modules. Okay, so let's go to the technical part. How do you define functions and how do you use them? And we saw this slightly when we talked about the main function and here and there, and you actually used, I think, in a few places functions. So def is the keyword in Python to define a function. After the keyword, you give you place the name of the function that you just decided on, and then in parentheses you list the names of the parameters that you're expecting from the user. And then normally those should be probably meaningful words, because later on in the function itself, these are going to be variables. So it's good if they are meaningful. In this specific case, because the function is so simple and so well, simple, just adding two things. So I use just x and y as the two parameters. And then I have the body of the function, which is indented to the right, the standard, usually 4 spaces to the right. And inside I use the function, the parameters to do some work. In this case, I just add them together with a plus sign, assign them to a variable called z, just to have something there. And then I call return. So you don't have to call return, but when you call return, then you can give it a value, and that's going to be what we call the return value of the function. In case you don't call return, then Python defaults to return none, the value none. Okay. So, but if you so there are functions that when you don't care about the return. I mean, you tell, for example, you have a function to write some file, and maybe you don't care, it doesn't have anything to return, okay? And then can be also other functions that don't have parameters. For example, you might want to get the current time. You don't give it a parameter, it just does something and returns something to you, okay? But then there are functions which have both. And I wonder if there is any function that has neither. It can be, actually, it can be. I mean, a function that does something and it doesn't give you any, clean the disk, okay? And you don't have to give it any parameter. And it doesn't return anything, it just removes everything from your hard disk. And you're finally free from computers. Okay, so we define the function. But this, when Python reads this doesn't have, at this point, nothing happened yet. Then later, you optionally can call the function. Obviously, I'm saying optionally because you don't have to, but if you don't call it, then why did you create in the first place? So you call the function in this way. You say add the name of the function, and then in parentheses, you give the parameters that you pass to the specific locations in the function. So 2 is going, so the x will get 2 in this case, and the y will get 3, because it's location-wise. And then add does the calculation, and the return value comes out here from the index assignment. So whatever the z was, the value will be assigned to a. In this case, 5. And then I can call it again with different values, and I get a return a different value back. Okay, so this is like the basics of writing a function. Okay, and we saw, yeah, so it was really simple to vary 2 parameters, that's it. Okay, now let's write a little bit more complex function. Actually, the function itself, the content of the function is not nothing special. It's just printing out some data, the parameters. The interesting part is what we call the signature of the function. So the list of parameters. So I have 4 parameters, okay? And so far, nothing special in the definition, really. It's just that I have 4 parameters. When I'm calling it, is interesting, because now if you only look at the call of the function, it's really hard to decide, 2 of my email addresses, doesn't matter. It's really hard to know, just by reading the calling of the function, who is sending it to whom, what is the subject, and what is the content. Because in order to know that, you have to remember which is the from field, which is the to field, which is the subject, and which is the content. And many functions receive even more parameters. And so when you're writing it, then probably your editor is going to help you and showing you what parameters and what are the names of the parameters and so on. Or you can look it up. But when you're reading it, you don't want to spend the time every time, okay, looking it up. Okay, so there is a much better way to call this function. Okay, and the way it's called is the next slide. I can call the function, I mean, if you look at it, I didn't change anything from the definition. Okay, so the definition is the same. But I can call the function this way. So I say subject equal to some text, content equal. So each one of the names of the parameters and equal what the value. In this time, at this time, we are passing the parameters by name. So the previous one was by location, and this one is by name. And if you see, if you notice, then I don't care about the order, because now the name tells me in which variable, which parameter to put the value. So I have the 2 at the end, I mean visually at the end, and if doesn't matter. Okay, it's longer than the previous one, so some people don't like it because of that, because it takes up more place. But on the other hand, it's much more readable, and that's quite an important thing. Okay, so it might be a little bit more work to write it, but it's a lot less work to read it, and it's much easier to notice if there is an issue. If you're sending to the wrong person, if you swap the to and the from by mistake. Okay. So we can also mix these, what we call positional by location. Okay, that's the other word, positional, and name parameters. Let's see this example. So here I have a couple of these parameters by name, and then at the end I have a positional. This won't work. Okay, so if I run this, I will get a syntax error. It says position argument follows keyword arguments. You always have to put the positionals first. Okay, so that's the only way to pass some of the parameters as positional, that you first put the positionals, and they will go into the first, second, and so on of the values. Otherwise, it wouldn't be clear to Python what do you mean.
So here, even if you wanted to give, like, I don't know, 2 as a positional, then you would have to give that in front and then call the keys. But then the position of it would be the first parameter, wouldn't it?
So let's go back to one of the slides that you might recall. So we had the sort function, or sorted, actually, the sorted.
Yes.
The sorted has to get the list first, because that's the positional, and afterwards gets the value key. So there we use the positional and the key value.
Yes.
Okay. The thing is that you won't decide, you won't say that, oh, I just want to pass the 2 as a positional.
Right.
It usually happens when you have some positional and some keyword. It usually happens when you have a very common parameter, and then usually, or if the function was written well, then that's the first parameter that you are expecting, that it expects, and then you will pass it as just as the first parameter, and all the rest are just key value pairs.
Like optional stuff.
Now the optional thing is, we haven't got to the optional yet. These are not optional yet. We are going to get to the optional parameters in a second.
So here, if you don't add 4 parameters, then the
so you have to add all the parameters. You have to pass all the parameters. Okay, that should be another slide here maybe, but yeah, you have to pass all the parameters as Python, as the function expects.
Right. Okay.
Okay. So in this one, so the example is not really good because there are 4 parameters that normally you would give all of them. You don't have a common one and the others are just maybe, or I don't know. Okay, so for that, it's not really such a good example. But the point is that you have to pass the. So if you decide if you pass some values positional, then those have to be the first ones. And now we get to the optional or default values. Okay, so they go together. What you can do is you can when you define the function. Okay, so that's now we are back to the time when you're defining functions, because the naming, giving a name or location or position, that's the decision of the caller of the function, the person who calls the function. But now the person who writes the function, and yes, I'm talking about two people, but they might be the same. So when you define the function, you can say that it has a default value, which can be also none. So you can say the default value is none. But you can say also just a number or something, anything. Okay? So this allows the caller not to pass that parameter. So because I gave default value to one of the parameters, when I define the function, when I call the function, from my point of view, that's just an optional parameter. Okay? So in this case, the content is not really interesting. Okay, that's really not interesting. What's interesting is that I can call this function prompt either with a single parameter, which goes into the question, and then retry is going to be 3, or I can call it with 2 parameters, when the first one is going to be the question, and the second one is going to be, the retry is going to be 1. Okay, so this and calling it with names are 2 orthogonal decisions. Okay, so maybe I should show here. Let me check. Okay, now it just let's go to check the source code of this. So it's called default. Okay, so I call this way, but and maybe I should actually not just comment this out, because it's not interesting, and just print out the question and print out the retry. Okay, it's gonna be, I mean, the content is really not interesting. But then I can show you, okay, and I don't need to call print here, because it's really not interesting in this, in our context. It might be interesting for the use of such function, but not in our context. So I can call it prompt, and then I can say hello, and I can say retry equals to 7, let's say. Okay, and I can also call it, shall I put an example with you as well? So I can say retry 42 times, and question, okay, that's not a question, but anyway, so now it's a question. Okay, so if I run this program, okay, maybe I'll change so it won't be your name all the time in the slides. But so when you run this program, you can see that all of these cases work. Okay, so I can give just the text, and then the defaults to 3. I can give a value, and I can also use the names. So the names, so the decision using the names and using just one of the names or both, that's sort of orthogonal the two, or the two decisions. Okay, let's keep it this way, and then I'll think about it, how to put it on the slides. Okay. Okay, so you can also have several of the attributes can have defaults. Okay, so in this case, B and C both have defaults. And then there are all kind of examples, just it's not really interesting. You go over which cases it can be. Basically, there's one important rule here with the defaults, is that all the parameters that get a default value must come at the end of the definition. So you can't define a function let's say, let me so if I define a function like this, I don't have any idea here. Okay. So let's try this one. So I define the function where the first parameter is supposed to be default, and Python says you can't. Okay, the non-default argument follows the default argument. So you have to first define the ones that don't have default, that must be there, and only after all of the ones that have default. Okay, and you can have as many of them both, but just that's the order. Okay. Yeah, basically that's it. Any questions here? Okay. There are cases when you would like to be able to receive an arbitrary number of arguments. The most obvious example for me is the sum function, but it can be anything else. It can be a function that receives as many file names as you would like, and then works on those file names, or as many as many sequences as you like. That doesn't matter, okay? You just give it some values. And it's quite easy in Python, not in every language, by the way. In other programming languages, that's not that easy to do that. In Python, you can say that I can accept here as many values as you like by using this star at the beginning of the name of the variable, or in front of the variable. Okay, so now I'm saying that I'm expecting some values. I don't care how many. It can be actually 0 or 70 or as many as you like. Okay, and this is how I'm going to call it. So my sum is 1 parameter, or is 2 parameters, or 3 numbers. Okay, it doesn't matter. What you get inside, so this numbers is going to be actually a tuple. I don't know why I didn't print. You can see it here. It's a tuple. So the parentheses show that it's a tuple. Okay, so you get the values as a tuple, which is just an immutable list. So it's just so you won't change the caller. Okay, sort of, that would be strange. Anyway, so now you can, for example, iterate over those numbers and then add them together. Or if they are files, then open the files, or do whatever you like. But the point is that this way, it's quite easy to get as many as you like. The question arises, what happens if I already have a list and now would like to pass the list to the, I think the screen has already, no, you're still, okay, there, okay. For a second, I thought that it was frozen, the Zoom. Okay, anyway, sorry.
Yeah, my connection is not great today. I'm sorry, I don't know what's going on.
Okay. I hope we can continue it easily, or that will work. Anyway, so what happens if you already have a list and you would like to pass that list of values to this function? If you just pass the actually variable x here, then this thing will receive a single value, which is the list. Okay, that's not what you probably wanted. You probably wanted to have the content of the list being passed there. Okay, so for then at that point, what you want to pass is the star x. So in this case, the star, it's sort of the way I try to explain it is that it peels off the listy properties of that thing. So as if you would remove these things, and then suddenly you only have the content, and that's what you are passing in. Okay, so yeah, I don't have the output of the last one. Apparently, I didn't update the slide here. But this would just show you the four values of that I passed here. Actually, let me update the slide. So it's functions and sum dot py. So let's just see what happens if I call my sum x, and I'm afraid that this will just blow up. Yeah, this won't work, but because you can't do the plus operation on it. But here at least you can see that what we got is a tuple of a single element, which is a list. And this is not what we wanted. Oh, sorry. What was the name of the function? Sum. So let's turn it around. Okay, and now it will still blow up, but at least it will run the first one. So now you can see that this worked, the one where we peeled off the listy property of those values. And then the next one, well, we got this one, and it blew up because of trying to use the plus operator on the list. Okay, so that's okay. So it blew up here when we tried to say total, which is an integer, plus s, which is a list at that point. Okay. Here too, you have a rule that okay. So you can, in addition just to accept any arbitrary number of values, you could also say, okay, but I also have a couple of fixed ones. Okay, for example, here I have a super my sum that can either add number together or multiply them together. Okay, whatever. But we have to pass in the operator as the first, as a parameter. This parameter, because it's a fixed and a required parameter, this must come before the star something. Okay, so that's another rule. Oh, and you can also, I don't know if Python limits this technically, but there is no point of having two variables with star. So probably Python will say it so, that if in case you would, because the first one is just gets all the parameters, and the second one wouldn't get anything. So there's no reason to do that. Probably Python will also stop us from doing that. Okay, so this is just showing that the fixed operator must come before the eat everything operator. Okay. Then there is other of these starry things. Did you want to ask or something? No. Okay. Okay. So you can also use two stars. Okay. So the single star would consume all the single parameters that you pass, all the parameters that you passed positionally that didn't have actually where to go. Okay. But you can also pass parameters, key value pairs. And there too, you can pass them to variable names, parameter names that were defined originally, like we had it earlier, or you just can pass arbitrary pairs, arbitrary key value pairs. And you can do that if the definition of the function includes this double star something. It's usually called KW, though it doesn't matter. Okay, it's key value, but I don't know why it's called. It's used W sometimes. So keyword, I don't know. In any way, if you have a double star in front of that, then it would consume all the key value pairs that didn't have where the key is not corresponding to any of the actual parameters that we defined, which in this case we don't have anything. So now if I pass in A equals something, B equals something, that this KW is going to be a dictionary built up from these. So this allows us to a lot of flexibility of writing a function. In the general case, you wouldn't do this. I'm trying to think, when do I really need this? I don't have any idea right now. Where would you need this in sort of the normal cases? I use this when I'm in the advanced part of, well, I teach it in the advanced part when actually uses for it. When you are creating functions that can generate other functions. And so in those cases, you will definitely need this, because then you don't know what the user passes in. But in like the normal cases, there could be. I mean, there could be cases when you say, okay, I have no idea what the user, I don't want to control what the user passes in, just key value pairs, and I will just handle them. Okay. Here too, again, you can have extra, so a fixed parameter and extra key value pairs, just like we had with the single star. And these two, the fixed one has to come before the 2-star one. And the final slide where you can, well, I have all the options here you can see. So we have a variable which is just a positional variable. Then you can, and you have the positionals. Then you can have a bunch of these that have default values. Okay, so still positional, but now they have default values as well. Then you can say, oh, I also get all the positionals that you still haven't consumed. And then if you still have key value pairs, then just consume those as well. So it's this like a very generic way of defining function. You can have everything here. I guess there is use for this, okay? Besides or beyond having a slide, you'll encounter it and I will use it, okay? Good. So I think you asked about this or something related to this, but let me show you what happens if, a long time ago you asked, the beginning of the course, what happens if we define a function that already exists? Okay, and I think you asked it about functions that Python provides, but this case, it's also true about our own functions. So the second one wins, the last one wins, okay? And Python doesn't say anything about it. So here I have a function defined, add, with 2 parameters, and I can call it, and it works because relatively to this is the one that is defined. And then when we get to this point, Python defines the next one, and then that doesn't work anymore because our definition now, sorry, wrong explanation. No, while I was explaining, I was thinking, okay, it's not true what I was saying, Gabor. Okay, so the way it works is that this gets defined, and while you and still before starting to run, Python defines this one as well. Okay, so this is not executed yet because first Python goes over the whole code. Okay, so okay, now I'm getting confused by my own examples. So let's run this because, yeah, that's really bad when it happens. Duplicate, add, by. Okay, so 6 and 4. Why did it even work? Yeah, okay. So let's go over it again. This one defines a function with 2 parameters, and I call it with 2 parameters, and it works. Then I redefine it, having only a single parameter. If I call it at that point, okay, then it complains. It won't work because add function only gets 1 parameter, the one that it sees. And then if I call it, but I mean, it's commented out, so it won't break our code. But when I call it with 1 parameter, then it works. Okay, good. It's important to actually see what I'm doing. Okay, let me check if it's installed for me. Okay, good. So I don't have it in the slide, but I mention it here. Okay. So there are a couple of these tools in Python that allow you to what they call statically check your code. Okay, they are in many languages, many other languages, they exist and they are called linters. Okay, so there is something called PyLint, which just reads your source code and without trying to run it, it gives you all kind of advices, all kind of ideas what to do. So once you install this program, you can run it like this, what I did just say, PyLint and the name of a file, okay? And then it complained about lots of things, okay? The important one is this one, okay? The important one for us. You could, I could configure it that it will only complain about these ones. And so I can tell it, okay, this type of thing, I don't care, okay? This is a warning that there is no documentation. Okay, so I don't care in this because these are slides or because you decided not to care. Argument doesn't conform to snake case. Okay, snake case, it looks like this, okay, like a snake, okay? These are all these how do you define the variable names? You have all kind of these strange names, so snake case and camel case, and depending on how they look. Don't worry about that now. Missing function or method docstring, another complaint about missing some documentation. Okay, again, you can configure it not to care about it. This is what is really important for us because it says function already defined. Okay, so it's not, it's something that I use when I start writing larger applications, that I start to configure this and tell it to check various important things for me, because I don't want to make a mistake even later on. So maybe right now in my code, I don't have this problem, but I don't want to make it by mistake later on. So I have this test, something running this PyLint all the time on my code and checking for me for these serious things. Okay. Actually, I think if you were using PyCharm and we're really up to start showing it to you, and maybe you can also do it with Atom, I don't know, but in PyCharm it's built in, I think, and it always runs it and will complain while you are in the editor. And maybe you can also do it in Atom, okay? You can configure it maybe. Okay, recursive functions. Do you know what is a recursive function?
I'm not too sure, but I would imagine something that you call many times after each other.
Okay, I can hardly hear you for now.
All right, I don't know.
Okay, okay. So when you say it that way, it's easier to hear. Okay. Anyway, but you probably remember from math classes recursive definitions of I don't know, functions, of mathematical functions. So let's see. I think I have two here somewhere. Yes, maybe. I have one. I definitely have one here. So factorial. So one way to define factorial is saying it's n times n minus 1 times and so on times 1. Okay, that's one way to define it. The other way is the recursive way to define is say, okay, 0 factorial is 1, and n factorial for any n which is a whole number and a positive whole number is n times n minus 1 factorial. So you are defining the value of the function and place n by using an earlier result from the same function. And if you'd like to write it in a more functional style, then you say function in zeros place equals to 1, and function in n place is equal to n times function in n minus 1 place. It's like without the exclamation mark, it looks like functions. So here, this is the recursive definition because we define ourselves by our previous, by a value previously in a previous value in our series. Okay, a critical part of defining something recursively is to have the very first condition. Otherwise, it would never end the recursive calling. Okay, so this is also called the stop condition in programming. And the same thing you can do in functions. So you can write a function that calls itself. And I remember when I first learned it, it was really, really confusing. How can you use a function that hasn't been defined yet? Okay, but because it doesn't happen, I can't hear you now, you're also on mute.
Yeah, no, I was just saying that is very confusing.
Yeah, so the thing is that the function doesn't run when it's defined. Okay, that's sort of the key thing here. So here is the definition, okay? So it says in Python now, it's almost the same as we have here. The function fn is if n equals to 0, then just return 1. If otherwise, return n times and call the function again. Okay, so now we are using the function in the definition, but this is not executed. When Python tries to understand this, the internal part is not executed. So it's just a text, it's just an explanation, okay? Right, so there is this joke about the mathematician who needs to boil water, right? And then they give it 20 centigrade water to boil it 100 degree. So puts on the oven and boils it up, right? And that's okay. And if you give the mathematician a 40 degree boiling water, then it will cool it down to 20, and it says it's already solved. Okay?
Right.
It's sort of like slightly like relying on your previous results.
Right.
Okay. And just so the mathematicians listening to this, we were telling it while I was in math school. Okay, so just to be clear, we were joking about ourselves. Okay. So it's slightly similar that you say, okay, we do something based on previously computed values of the same series. Okay, but you can't do, you always have to have some base value that beyond that you don't need to recurse. So we define this, and while Python reading this, it doesn't execute it, so it's okay. It's just the explanation, nothing happened yet. And when we call it, when we call it with F1, what happens? Python reads this. It says n is not equal to 0, not is not equal to 0. So it says it's 1 times f1 minus 1. So it's f in the zeros place. So now it calls again f with 0. Is n equals to 0. Now it returns 1. And this never gets executed. So the previous call now gets back the return value, which is 1, multiplies it with 1, and returns the 1. And that's it. When you call it with, let's say, 4, what happens is that we call it with 4. It's not 0. So now we call 4 times f with 3. So now we call it f3. It's not 0, so we call 3 times f with 2. And it goes inside, and then when it reaches the f with 0, it doesn't go deeper anymore. And then slowly it gets returned back to the top. So in this specific case, it's probably not simpler than just writing a function that would go over the numbers. But in many cases, it's easier to write a recursive function. For example, if you have a directory structure and you have to traverse through all the tree and all the subtrees and all the subtrees. And I know that biologists also have these classes and subclasses and all these things. And in many places you have these, you can have dependencies, okay? So you might have that this thing depends on these things, and then these things depend on all the smaller parts and so on. And going through this whole thing, it can be complex. But if you say that, okay, I have one, now let's go over these ones, and going over each one deeper is just the same as what I'm just right now doing. Okay, it's probably easier to explain to, at least to the computer. Okay, so and that case is when the recursive functions can be really useful. In almost every case, actually, you can convert a recursive function to a non-recursive, but it's not always makes the code cleaner or easier to read. Okay. Anyway, so this is recursive functions. I know that in some universities, the computer scientists, they have like full courses where they force you to do everything in recursive functions or full exercises. It's totally crazy. I guess they want you to practice in the rare cases when you really, really need that. Sometimes they're really useful, many times not so much, okay? There's another example often shown with recursive functions, which is actually a really, really bad example, but let me show you. So Fibonacci numbers, do you remember Fibonacci numbers from math? So this is the definition, this is the recursive definition. For one, the first element of the Fibonacci series is 1, the second element of the Fibonacci series is 1, and the nth element of the Fibonacci series is the n-1's element plus the n-2's element. Okay, so this is basically the recursive, and Fibonacci doesn't really have another definition, just a recursive definition. Okay, and that's probably the reason we are showing it, but and so this is the implementation. Okay, that's really not that, it's really quite similar to what I wrote here. If n equals to 1, return 1, n equal to 2, return 1, and in any other case, just call it again and return. Okay.
Why do you say this is a bad example?
Sorry?
Why do you say it's a bad example?
Okay, so how long will it take? What is the complexity of this function?
I mean, it doesn't go very far because it always needs to go like 2 down.
Yeah, it's not very deep. Yeah, that's
no. Yeah.
Well, it
I mean, actually, yeah, because it has to go down all the way. Yeah.
Yeah.
Right. So what would that be? N times n.
Right.
Again, because actually no, n-1 times n-2.
Okay, you're getting close.
This is all I can come up with.
So first of all, I have to, okay, I'll just show you what Google says about what recursion is. So what Google offers as explanation to recursion is some text, and then it offers you maybe to look for recursion. And then it offers you to look for recursion. Okay?
That hurts.
So, yeah, they are geeks there in Google. So the Fibonacci function is like the super geeky function because the complexity of the Fibonacci function is the Fibonacci function itself. It's not n square, it's slightly less, which is and it's exactly the Fibonacci. So the number of operations you have to do is the same number of the Fibonacci.
Okay.
Yes. Okay, all the other biologists and chemists now I'm leaving, and they're okay. That's it for. Okay, don't worry about this. Oh, everyone else, if you feel that's just too much math, right? You're right. We don't do this. Okay, normally. Okay. So instead of that, what we do is write a non-recursive Fibonacci. Okay. So yes, you are right. Fibonacci is an extremely good example because the definition is recursive itself. So implementing it, but at the end, it's not a good idea to use a recursive because it's way too slow. Okay. So Oh, and yeah, just let me just go back. So for 30, this is the Fibonacci number, as opposed to have actually 30 operations. Okay, so this grows like, yes.
Right, yeah.
It's slightly less than square, but it's still quite bad. Okay, so this is the non-recursive version. So I have a, and actually what it's slightly different because it, instead of returning the nth Fibonacci, it returns the whole list.
But I mean, you can modify that to only show
Yes, that's easy.
The last.
Yeah. So, but I don't know why. I mean, maybe I should have it here also, the one that without the returning the list. So what I have here is for n equal 1, it just returns 1. For n equal 2, it returns 1, 1. So far, it's okay. And then we create an internal list called fibs, or whatever you like. And then we go over, range over, so you go over the elements from 2 to n, okay? Because you don't need the first two already. And what we do is we append to the fibs the last, we combine, we add together the last two elements, and we append that to the fibs list. Okay,
right.
So for n, that goes to going to be n operations.
Yeah, okay.
Okay, and then just we return the list, and that's it. Okay, so just to show why it's important, because it's gonna be 30 operations instead of 800,000.
Right.
Okay. Right, what else here? Yes, so here is a recursion function, beautiful one. It prints something in recursion with n, and then it calls recursion n plus 1. If I call it, it will just run and run and run until you press Control C, because we didn't have the stop condition. So it just calls itself and goes. Actually, Python protects us from burning our CPU, because that would happen. And Python limits, I think, so to 997, or I don't know, 1,000 more or less of the depths of recursions. And Python says it's really, really unlikely that in a real world situation you need 1,000 depths of recursion. It's way more likely that you just forgot to have the stop condition. Okay.
Right.
So it
Can
just stops.
Can you override this if you in fact need many recursions?
I don't know, maybe you can, but I mean, I'm almost sure that you would be better off rewriting your code not to use recursion.
Right, fair enough.
Okay. I don't know if you, I mean, I'm sure that it's somewhere in the source code of Python. So worst case, you could recompile Python with a different number there. Okay?
Right.
But maybe you can even access it some way, but no real point for this. Okay, okay, this is not really interesting here, but maybe we do need to go over that. Okay, so just a little reminder here, okay, because we have to, we need it for the functions. So here, if I have and assign a number to, it's not functions now, but we'll need them for the functions. Okay, so we assign a number to a variable, and then we assign just a to b, and we'll look at them. And if I change a now, then a changes, b not. Okay, it's the same with strings. Okay, so this assignment is basically it behaves like a copy. Whether what happens behind the scene exactly doesn't really matter. It just, they are sort of separated, the A and B. Okay. If I have a tuple here and assign, and then I assign a different tuple, the same thing. Okay. So because they are all immutable, the assignment behaves like a copy. Okay. When I change one of them. If I have a mutable something here, like a list, and I do this assignment, then if I change the content, not rewrite the whole thing, but change the content of one of them, which I can do, unlike with the immutable ones, then I change both. So this assignment is pointing to the same data structure. Okay, we talked about it earlier when we talked about the deep copy, when we needed the deep copy to separate them. Same with dictionaries. Okay, so I have a dictionary here, I make this assignment. If I change the name, then it changes to both of them. Okay, so this is for assignments. So now comes the question, what happens when you pass a variable to a function? And it behaves exactly as if it was an assignment. Okay, so if I have here this function, inc n, okay, what does it do? It takes the n, adds one to it, and returns whatever the result. And outside I have a variable called x, and it has 3. And now I call print x, so it's 3. And I call increment x. What increment x returns is 1 more, right? Because it got 3 and more, okay. And if I access now, print out x again, it's still 3. Okay, because this, when I pass the value to the increment function, it was like copying it. It was like an assignment. And because it's an immutable,
it didn't change.
because it's a number, okay, because it's a number, so it's not really immutable in that way. But because it's a number, it creates a copy of it. Okay? What happens if, the same would happen if you pass a string. What happens with lists? So here I have a list and a function called update that gets a list and changes one of the values. Okay? I have, later we look at the change function. So I print numbers 1, 2, 3. I call update and I print out the numbers again. And it updated the numbers, which is outside of the function, okay? So think about it now, the function changed the external world.
Right.
Okay? Which is in the end not a good idea to do. I'm showing it exactly for that reason. So it's sort of like, okay, remember that if you get a list, you probably shouldn't change the content of it, unless it's clear that that's what the function does. Okay, there is this other function, it's called change, which again gets a list. It replaces the list and returns it. So when I call change, it returns, so the print here, whatever it returned, the original list doesn't change. Okay, because now I replaced the variable.
Right.
Okay.
Right.
So instead of here, I changed the content of the list. Here, I replaced the whole thing. So, and then now it's got separated, the outside list and the inside list.
Yeah, I mean, it's two different lists. Right, okay.
Okay.
To clear it up, yeah.
So this question, so the question in general that programmers ask when they learn a programming language is whether the function, the passing of variables is passed by value or passed by reference. These are the programming term for these. So if you pass by value, then only the value gets inside. Whatever you do to this value inside doesn't matter. And if you pass by reference, then whatever changes you make, it reflects the outside world. In Python, I wouldn't say it's, so if it's immutable or number, then it's passed by value, definitely, because whatever gets inside is just internally. If it's a list, then you can change the outside world, but if you can replace it, then it's not that anymore. Okay, so it's not exactly what in other languages. well, for now, what it's important for us is that's how Python behaves, and I mean, hopefully you won't get into a trouble that when you encounter this, that you change something internally. But it's good to remember that that this can be a source of problems. Okay, what else do we have? Too many more slides. Okay, I don't know how many more. Oh, documentation. People don't like to write documentation, but if you really would like, then the recommended thing is that after you have the definition of the name of the function, before the content, you just put in some string, and that's going to be the documentation of the function. So if anything would like to look at your documentation, it will look at that. Okay, and you can even have access to it while you're running your program, which we'll use later on. Okay, but just if you'd like to write documentation for your program, for the users of your functions, or that's the good place. Okay, it's not interesting, I think. Yeah, so I have a couple of, what do I have here? A copy-paste code. Okay, it's gonna be interesting to go over this. I remember when I created it, but I think there is some issues here. So let's see, we have 3 lists here, okay? And what do we would like to do? We'd like to compute the average, okay? So we have some code, okay? We computed the average. That's not a big issue. And here are the results. So look at the numbers, look at the results. Are they okay? I mean, we don't know, okay?
I suppose.
I'm not expecting you to see that, especially not after an hour or so that we were talking about functions, okay? Can you see the bug in the source code?
Yes. So okay. the last one, there you're dividing by the length of A, not the length.
Okay, so that was actually quite fast, but yeah, it's really difficult to notice this bug, okay? And especially if you don't look for the bug, because I mean, I got numbers, okay? And then you go on and you write your whole PhD using this, then your dissertation, and well, numbers are not the right ones, okay? So it's a problem, okay? But the part of the source of the problem is that we have the same code again and again. And at one point, I guess what we did is just copy pasted it, and I forgot to update one of them. Okay, so what can we do here? So the first thing is, well, you can, what did I do here? I created a function. Okay, so here is a function called calc, gets numbers, and then it goes over the numbers, which is assumes to be a list, I guess. Okay, it goes over the elements of this list and adds them up together, and then returns the total and the average. And yes, I don't care about actually having 0 number of elements, like the one that I mentioned to you earlier. Okay, so I have this function, and now I can call this total the same things. Okay, so I can that's one way to fix it. Now I have everything here. I still have some duplication here.
You could replace that with a for loop.
Right. It's for loop on what?
So on the 3 lists.
Yeah, but then I can write for and then put a list of A, B, C.
Yeah.
But then how would I print out that I'm saying A and B and C? I would have
format it.
Can a variable tell what its name? Yeah, I think actually they can. So maybe you can do this. Yeah, maybe you can do this. Okay, good exercise. What I did is I made a different choice. I changed the data into a dictionary where the A, B, and C were the keys, and values, the lists were the values. And then I had this loop and doing the same thing. But maybe you can actually use the reflection of Python. So to ask the variable what is its name. Could be interesting. Okay, last slide. What is a palindrome?
Something that is the same from the front and from the back. It reads the same thing.
Yeah, I should have the explanation here. I don't remember. Why do I have it here? Okay, doesn't matter. Yeah, it's okay. So because it has an iterative and a recursive solution.
Okay.
Okay, I don't remember. I'm sorry, I don't remember why do I have this slide here. Well, it's a good exercise for you to look at it. Okay. Something I wanted to try here. Now, I don't know. I was trying to figure out if I can ask Python what is the name of the variable.
I mean, why would you, for the sake of that exercise?
For this one, yeah, for this one. Because,
why would you need it?
Because I wanted to print out A and B and C itself.
Yeah, but you just say for I in A, B, C as a list, and then just call I.
Yeah, but I contains the value, the content, not A.
Right.
That's
okay.
A.
Okay.
Yeah. So that's what I think. That's why I created that dictionary, because I didn't know how to.
Right.
Maybe it can be done. I'm not sure if that's the right thing to do here, but that might be a solution. Okay. Let's go over quickly the exercises, and then let's stop this video and let you do the exercises. Okay, so a couple of these exercises, the statistics. So just a function that accepts a number of numbers, and returns a list of values. So returns these values. Actually, I haven't showed that, I think, yes. So let me show you this one. Yeah. What I'm trying to do is to show that, well, let's just to make it clear that what's going on, I'm creating two variables as well. And then I'm calling it Z equals to calc 2, 3, and Z, and what else do we have? Q. Okay. So I can call this, and it doesn't do anything or doesn't print anything. And I can print out Z and print out Q, and you have the two values. So what I was trying to show, that when we call return, you can give it a number of values, and they are returned. And
what if you say just one variable? So like just say Z equals calc 2 and 3 without the Q.
So let's keep this one, but you say this.
Yeah.
Let's see.
Ah.
What is this?
A tuple.
Yep. Okay.
Okay.
So let's call it T. And let's give it 4 and 5, just so. Okay, and now we have both examples. Okay, I'm going to add the slides, so we'll have them. but you need that really this knowledge you need for the exercise. Okay, exercise recursive. So yeah, so this is like this dependency thing. So you have a bunch of files like a.txt and b.txt and c.txt, and the a.txt has letters in it, basically saying that A depends on B, C, and D. And B says that it depends on E and D. And there is nothing about E, okay? So someone depends on it, but E doesn't depend on anything. It's just apparently there. So the requirement is just to print out the tree, or not the tree, just all the dependencies, everything that we need. Okay, and here, for example, we have D twice. So that's also a question what you do when you encounter the same thing twice. Can you handle loops here? That's also an interesting question. What if something depends on something that, yeah, so probably it's better to deal without loops. Okay.
Right. I'm not exactly sure what you want us to do here.
Okay, so you, I have, okay, so let's talk about chemical elements here. And then, so this chemical construct is built out of these. And then the one that's called B is built out of these. And I would like to just to have when I give you A, I would like to give you the whole, all the details of it.
Right, okay. Okay, I think, yeah.
Yeah, once you convert it to chemical elements, it works. Okay. Okay, so there's another exercise which probably you should skip unless you really like to you play. So there is I'm not right. Yeah. So it's not an easy one, but right. It's not an easy one, but it's solvable, and it's definitely one of the key examples of using recursive solution. So do you know the Tower of Hanoi?
Nope.
Okay, so let's go to the Wikipedia page. This is a game that looks like this.
Yes, I do. I just didn't know it's called like that.
You have to move it, the plates with one rule that you can, two rules. I think you can only move one element, and then any time the smaller ones have to be above the bigger ones, and you have to move all of them to the last one. Okay, it's not an easy exercise, but it's solvable. Whoa, that's okay. So sorting. Okay, let's quickly explain about sorting. So when you're sorting things, there are two main parts of the sorting. One of them is how actually compare two things. When you're sorting two people, whether you compare by height or by weight or by first name, or okay, so that's where it's usually important for the programmer. What is more important for the programmer scientists or the program scientists is in what order do you compare each two of the elements? Okay, so do we pick up the first two and then the first and the third one, or in which order do we compare them? And there are several of these algorithms, and some of them have the complexity of n squared, others have complexity of n log n. I don't think that there's anything better than that. The interesting part actually is that many times the n squared is faster, because the n log n has a huge constant multiplying. Okay, and in most cases in the programming world, we actually have short lists, so the square doesn't bother us so much. Anyway, there are two listed here. One is called bubble sort, and the second one is called merge sort. And my request in this exercise is that you try to implement both of them. And then I think actually have a couple of more exercises now that I thought about them that we have. So So yeah, if you would like to, it's explained here in Wikipedia. Okay, I don't want to get in there. Merge sort. Yeah, it's also explained here. So you divide basically what you need to sort into smaller things. You sort all of them and then you merge them together. Okay, there are a couple of these different algorithms, and it's interesting to implement them with just Python. Okay, just to see, it's a good exercise. But even better is to go back to, and I don't know why I don't have it here. I should add that as an actual exercise. Go back to the number guessing game. Okay, and in the number guessing game, take and move pieces out to functions. Try to put the whole thing into a single function and then put pieces into functions. Try to think how, and I don't have the exact definition for what, so how, but try to think what you think could be interesting to have in one function, and what values you need to pass, and what values you get back. So you have everything inside a function. Try to do the same with the other exercises that you, so basically you can pick any of the older exercises you have, especially the ones that are longer. But we also had one recently with the dictionaries that I mentioned, that it's good, it can be a good idea to put them in functions and try to convert them into a code where you have a function and you don't have, if possible, you don't have any variables outside of the functions. So everything inside the functions, okay? And yeah, and that's sort of the exercise, thinking about how you write functions. Okay? I'll write down this also for text, but that's basically it. Any questions?
No, not for now. I'm sure I'm going to be very confused when I'm actually doing it, but we'll get to that.
Okay, so thank you for staying and listening, and thank you very much for watching the video, and go ahead and do the exercises, and we'll get back to next video with the solutions. Okay, so bye-bye for now.
See you.